Okay, welcome to this video on periodic trends parts 3 and 4. So you've already watched the video and started your notes on 2 periodic trends. This video is for the final 2, the octet rule and electronegativity. So as a reminder, you're continuing your previous notes, and at the end of assignment 3.4, you will submit your pictures for all of the notes. And if you need access to these slides to review anything, remember assignment 3.4 has you covered. Okay. So we're starting with something called the octet rule. So the octet rule is basically the reason atoms form bonds. So the reason atoms form bonds with other atoms is to try and be as stable as a noble gas. So if you remember, noble gases are group 8 on the periodic table, and they are so stable because they have what's called a full valence energy level, a full valence shell. So we learned that valence electrons are our outermost energy level of electrons, and particularly our noble gases have a full one, and that's what makes these atoms so incredibly stable. All elements want to become electronically stable like the noble gases. This means they want a full valence shell of 8 electrons. So atoms will give up, steal, or share valence electrons with other atoms in order to get the magic number 8. And you'll see that they're going to do whatever is easiest for them. They'll either give up all of them in their outermost energy level, or they will steal. Sometimes they share if they have to. And that's what forms bonds, is all of these atoms trying to become as stable as possible. If atoms give up or steal electrons, they are no longer neutral. We call charged atoms ions. This is a really important term that we are not getting rid of for a while. So we talked previously in radiation about when atoms are neutral, they have the same number of protons and electrons according to the atomic number on the periodic table. What we're going to start to learn about is, well, they aren't always neutral because they give up or steal electrons. So if we change how many negatives are in an atom, then now we do have a charge. An ion with a positive charge, so it's lost electrons, so now it has more protons than electrons, is called a cation. Cation. An ion with a negative charge, because it has gained extra negatives, it's stealing electrons, is called an anion. So cations and anions. And here's just a quick visual. This is also something that you might want to draw in your notes as well. So we can see we have a cation over here. I know that it's a cation because I have 1, 2, 3, 4, 5 protons. So I have 5 protons, 5 positives, but only 1, 2, 3 electrons. So that means I have an overall positive charge because I have more protons than electrons. Over here on my anion, I only have 1, 2, 3 protons and 1, 2, 3, 4, 5 electrons. So because I have more negatives than positives, I have a negative charge, more electrons than protons. And these can occur in any number. But the thing we want to note is how many protons to electrons. More protons means positive cation, more electrons means negative anion. So we can have some big trends with this octet rule based on these ions that form. Metals, those other than hydrogen that occur to the left of my staircase on the periodic table, tend to be shiny, lustrous, malleable, ductile, and good conductors. They like to lose all of their valence electrons. That's what they tend to do. They lose all of their valence electrons to form their octet because it's easier for them to lose their couple valence electrons than to try to steal a bunch of them. So in general, metals become positive cations. Definitely want that in your notes. Metals form positive cations because they lose those negatives. They lose electrons. And here's an example of that. So we have my sodium here. So my sodium typically has 1 valence electron. But if it loses its 1 valence electron, now look at that. It has a full shell of 8 ready to go. It's much easier for it to just lose that 1. It's the fastest way. So this is now a sodium ion because it has a charge, Na+. Charge of +1 because it lost a negative. Here's a couple more examples. So losing 3 electrons means you have a charge of +3. So here's my aluminum. We have 3 valence electrons. I know it has 3 because it's in group 3 of my representative elements. And if it loses its 3, it now has a charge of +3 and a nice full outer shell. Nonmetals, you might predict, are the opposite. So these are typically dull, brittle, soft insulators. Some are gases, and they like to do the exact opposite. They're going to gain enough electrons to fill their octet, becoming negative anions, because it's what's easiest for them. So let's see a few examples. So in my example of chlorine here, right now it has 7 valence electrons. It's so close to having 8. So what it's going to do is it'll steal from a neighboring atom. It's going to steal a valence electron. Now it has 8. It's met the octet rule. It's happy, but it has a charge. Something like down here, we see that oxygen has 6 valence electrons. It wants 8. If it gains 2, it now has a charge of -2, but a full valence shell of 8. It is more stable this way. Semimetals are weird. They can't decide. They have properties of both metals and nonmetals. They don't often form ions. They're going to bond in a different way that we'll see later on. So we can predict our metals and nonmetals. Semimetals, not really. Here's an example of semimetal boron sharing valence electrons. This is a whole different type of bonding that we'll learn later on, but you might recognize the structure here, those dot diagrams that we had been practicing. Here's a quick self-check. Go ahead and pause the video here. Try to answer. Welcome back. So the octet rule is where atoms want 8 valence electrons, and they're going to do whatever they can to try to get 8 valence electrons because they are most stable that way. Number 2, an atom with only 2 valence electrons in group 2 is a metal. It would be most likely to meet the octet rule by losing those 2 valence electrons and forming a positive charge, +2 cation. An atom with 5 valence electrons, well, that's in group 5, and it's more likely to gain 3 valence electrons. And if it gains 3 valence electrons, it would have a charge of -3. Last one, electronegativity. So electronegativity is the measure of an atom's ability to attract electrons, and it's an actual number. So you can see on this periodic table there's a number assigned to everything but our noble gases here. And it increases as you move to the right and up on the periodic table, except the noble gases, because they have no affinity for electrons. So you can see my most electronegative here is fluorine. Pause this video and draw the arrows on your periodic table. This value, the reason we care about this value is because it's used to predict how an element's going to bond. Something with low electronegativity is more likely to lose valence electrons. High electronegativity is more likely to gain valence electrons. Just another visual for you that I thought was pretty helpful. Go ahead and pause the video and complete this self-check, and I'll see you back here in a sec. Welcome back. Question 1, would oxygen be more likely to lose or gain electrons to complete its octet? Oxygen on the periodic table is a nonmetal. Nonmetals are more likely to gain electrons to complete its octet. It would gain 2, forming a charge of -2. Barium is a metal. It would be more likely to lose its valence electrons. It is in the second group, so it would form a charge of +2 for losing 2 valence electrons. That's all we've got today. Go ahead and submit your notes to assignment 3.4. Use the slides also available in assignment 3.4 if you need any review.